So first I'm not going to check any condition. So without condition, we want to do like a loop means then it should be definitely do while loop. Okay. So if without condition, I have to check the conditions. Okay. So what I have to check? So do again condition I plus plus. I should keep move on. How many times I should move until and unless if the value is greater than pivot? Means if a of I value is less than or equals to pivot, then you keep on shifting the elements. Similarly, after I position has been fixed, who should start its work? J should decrement. J minus minus. How many times it has to shift? Until and unless it has to shift. If the value is, if it is less than pivot, then stop it. So what we have to write? We have to write in the reverse direction. If A of J is greater than pivot, then you do the work. Otherwise, stop the work. Okay. So whatever the values are hot. Okay. So what is first? Do. In the do while loop, again I'm writing 2 times do while loop. First one, I value is setting its position. How many times I pointer is going to be shifted until and unless it is going to get a greatest value than pivot. Okay, how many times J is coming backwards until and unless J is going to find a smaller value than pivot. If it is greater, okay, I have greater, so it will shift. If it is smaller, then it will stop. Okay, so how we have to shift the elements? First 26 is compared with 54. 26 is smaller than 54, then shift the I value. Next, I is going to come to which position? I is going to be coming to the next position is 93. I is coming over here. Now 93 is compared with 54. Yes, definitely 93 is greater than 54. Then I pointer is going to be stopped over there. If I pointer is going to be stopped over there, immediately which one should start its work? Immediately J should start its work. How J is going to be comparing? If value is smaller, stop. If value is greater than pivot, go, continue. So first, where J is starting with 20. The value is greater than 54. No, smaller than 54. Where J will stop? J will stop over here. Okay, if I and J are going to be set its position, then what we have to do? We have to do the swap. Which two values are getting swapped? I and J values are going to be getting swapped. Okay, so how we are going to get the next array elements? The next array elements are 54, 26. In the place of 93, 20 value we are going to get 17, 77, 31, 44, 55. In the place of 20, which value we are going to get? J value we are going to get. So this will be swapped to here, and this value is going to be swapped over here. So what we have to do? If what is the condition? Is I position is less than J? Yes, I position is less than J. What we have to write? If I is less than J. These two are continuous loop until and unless it is going to get the position. If I is less than J, what we have to write? Swap of ampersand of A of I, comma, ampersand of A of J. Who is this ultrasonic? Yes, so how many times we have to do this work? This work we have to do until and unless I is less than J. Here students, I told you it's an entirely different code how we have written the previous code. Okay, so many milestone because we are shifting the elements and we are set writing. We are shifting the elements and we are set writing. Okay, what we have to do? First shift the I pointer, check this greatest value greater than pivot. then shift the J value. J should moving backwards, okay, until and unless it is going to find an element which is smaller than the pivot element. And the next, if I value is less than J, means I position is less than J position, then swap the elements. This whole loop should repeat how many times? Until and unless if I value is less than J. So what will happen if I value is greater than J? Then we have to write the continuation code. Now, what are the array elements we are having? 54, 26, 20, 17, 31 and 53. Okay. So now J will come to the next position. I will move to the next position. So I is coming over here. Okay. 17 is compared with 54, smaller than 54, I shifts, then I shifts to 77, 77 is greater than 54, then I stops over there. Now J starts its work from over here. 55 is greater than 54, it won't stop. Then J comes over here. 44 is greater than or greater than 54, no, smaller than 54. If it finds smaller, then it will stop. Now, so first two loops. What are the first two loops? I plus plus, J minus minus. Yes, we did. Now the condition, what we have to check, if I is less than J, yes, I is in which position? Somewhere in the 5th position. Where is J? J is in 7th position. I is less than J. Yes, I is less than J. What we have to do? We have to do swap the elements. Yes, which two values are getting swapped? I and J are getting swapped. Okay, what is the new array we are going to get? 54, 26, 20, 17, 44, 31, 77, 55, and 93. Yes, this is the new array. In the place of 77, we are going to get 44. In the place of 44, we are going to get the 77. Now, I shifts to which position? I is going to be shifted over here. Okay, I has to find the greatest element. Then I has been shifted over here. J is over here. J already crossed over there. Means now I is not less than J. I is greater than J. If I is greater than J, okay, so then don't do any work. Stop doing the work. Stop the loop. So our loop means whatever the code I have written, while I less than J, then only we have to do all this work. If I is greater than J, I index is greater than J, I index is greater than J, then don't do any work. Then you have to swap. Which two values you have to swap? You have to swap the J element with the first element, pivot element. Okay, so what we have to write for the code? We have to swap two elements. Watch which two elements we have to swap. Swap of ampersand of A of J element, A of low value. First, A of low we have considered as pivot. No? That value should be considered, changed and swapped with which one? A of J. So now return J means the positions we are returning. Close the loop. This is going to be called as partition code, students. What is meant by partition? First, we are going to get the position of the 54th element. Suppose if these two are getting swapped, so how it will be? 31 will come first. 31, 26, 20, 17, 44, 54. What are the last three elements? The last three elements are 77, 53, 93. So the first element, which element we have fixed? The first element we fixed with its position. If we are going to see the left hand side, all elements will be smaller than 54. If we are going to see on the right hand side, all elements will be greater than 54. Okay. First one, we have to divide the array into two partitions. So that's why I have written the partition code. The first one is partition code, students. So what is partition code? Take the array. Okay, I have taken the array. Next, First element should be the pivot element. Yes, the first element is the pivot element. I is going to be the low, means the zeroth element. J is going to be the high, the last element. What we are doing, we are simply sliding the I pointer and J pointer by checking a condition. What is the condition? I should stop if it is getting greater than the pivot element. J should stop if it is going to get the smaller than the pivot element. Okay, so first I pointer is shifting, next J pointer is shifting, and one more condition we have to check every time, that if I is less than J, okay, now we set up the pointers. Okay, I was stopped at 93, J was stopped at 20. So now we check the condition. If I is less than J, yes, I is in which position? Second position. J is in N position. I is less than J, then swap only I and J. So what I have written, swap A of I and A of J. Now we have repeating the procedures. Now at a particular case, I got that I has moved forward than J, then stop the work. So what you have to set up, you have to bring the pivot element not with I, students, you have to bring the pivot element with J. So if this condition is not working, swap of A of low with A of J. So this is the partition code. This code works repeatedly. Now take the remaining array elements. What are the remaining array elements we are having? 31, 26, 20, 17, 44. First one, pivot element. This is going to become the pivot element. This is I. This is going to become as J. I is the lowest value. J is the highest value. We are partitioning the array. Next one, I plus plus. When I should stop if it is going to find the greatest value. When J should stop, it should find the smallest value. So 26 compared with the 20, no greater than. 20 greater than 31, no greater than. 17, no greater than 41. I is coming over here. Who starts its work? J starts its work. J should start its work by checking with the lowest value. 44 is greater than 21. No, 41 is not greater than 31. Now 17, J is moving backwards. Now J is coming over here. So, but the condition whatever I have written has been failed. While I is less than J, then only you have to swap. Now I is greater than J, then what I have to do? I should not do any repetitions. I have to stop the work. Where I have to stop? J should stop over here. The pivot element is at the stop. So if I is greater than J, then swap the J value with the pivot element. So now 31 is coming over here. 20, 26, 17 is coming over here. 44. Now we are dividing the array into two parts. 31 and 44. If you are going to see, right hand side all greater elements will be there, left hand side all smaller elements will be there. What are the elements we are having? 17, 26 and 20. 17, 26 and 20. Again repeat the same procedure. 17, 26 and 20. We have already fixed the value 31. 44 is only the one element. No need of doing the same work once again. 17, 26 and 40, which is the pivot element. 17 is the pivot element. Where I starts over here. 17 is compared with 17, no value. 26, then I is going to shift over here. Is 26 greater than 17? Yes. So it will stop. Now J starts over here. J should find the smallest value than the pivot, okay? So J is 20. 20 is greater than 17. Shift. 26. J is compared. 26 is greater than 17. Shift. What happens? J is coming over here. Okay. So what is the position? J has been and J should be shifted. Already it is there. Already J and the pivot element of the least elements. Then what are the remaining array elements we are having? Only 26 and 20. which is the pivot element. 26 is the pivot element, which is the I value. I value is here. I should shift to the left hand side, only one element. J should shift to the right hand side, only the one element we are going to have. Then shift the elements. So 7, 20, 26. So from this array, what we got? 17, 20, 26. Already 31 and 44 has been sorted. So if we are moving backwards, so what is the next element we are going to have? 54 was already in its place. So like this, the array is going to be divided partition way, and we are going to do it. So these are the steps of the partition, students. I don't know how many of you are listening, making a note, doing.
Ma'am, I have a doubt.
Yes, tell me.
Ma'am, in the second do while loop where we are checking the J, we are doing the J minus first, then we are checking the condition.
What no, first we have to do I value should be greater. First I pointer should move, next J pointer should move. Okay.
After the I pointer stops, after it finds the element, when the J pointer starts moving, what if the first element in the J pointer is greater than the pivot?
Can you give me a scenario?
Ma'am, can you show me the array once? The first array. Ma'am, over there in place of 20, what if there is 55? Like 44, 20 and 55.
Just give me any three to four elements. Will work once again.
Ma'am, 54.
Okay. 54.
54, 10, 44.
44.
20.
20. That's it. Okay.
No, the last element. What if the last element is greater than the pivot element? So if after 20 there is 55.
55 is there. Yes. Okay. Now this is the first element, pivot element. Okay. This is I, and this is J. Yes or no? Now I pointer should move 10 smaller, 44 smaller, 20 smaller, 55 greater. So I is coming to the end of the loop. Okay, whether it is coming to the end of the loop, leave it. Okay, I is coming to 55. Okay, if I is going to find the first position, then what has to start? J has to start its work. What J has to find? J should find the smallest value. So J starting 55 is greater than J shifts, 20 is smaller than 55, then J stops over here. But the condition is already I is greater than J. If I is greater than J, we should swap between 54 and 20. 54 and 20 means 20 coming over here, 10, 44, 54 and 55. So which element has been arranged? Pivot element has been arranged its position. If you are going to see, the array is going to be breaking into two parts. Right hand side, the greater elements of the pivot. Left hand side, the smaller elements than pivot. Yes? Yes, yeah.
Ma'am, but like how the J is working, because we are doing do while, so the minus will happen first, then it's gonna check the condition.
Oh, like that only I have written, no? See.
So once it get in the starting of the loop for the J, if it at the first only gets the element that is greater than the pivot, then how it gonna decrease the value?
J is not checking the greater values, no? J is checking the smaller values, no?
So if it comes to greater, it's gonna stop. Okay.
Okay, it is not going to be bothered whether if we are going to get the greatest values.
Okay.
J is always checking the smaller values than pivot. I is going to check the greater values than pivot. Okay. Yeah, students. I don't know how many of you are listening to the class, but listen carefully how you have to work. I'll show clearly. You have to write the answers like this, students. Then only you are going to get the marks. Otherwise, you are not going to get the marks. Listen carefully. Why I am going to say this many number of times. So they are going to give the values clearly. Okay, they will give an array. You people have to write like this. This is a direct question, students. Direct question, quick sort, selection sort. All these are direct questions. It may come for theory and it may come for practical also. So they will give the values. The array values are 54, 26, 93, 17. The same example, whatever I have taken. Because in the class I have explained 2 to 3 examples. So you people have to write like this. Where I is going to be stopped, where J is going to be stopped, what is the condition you have returned, and which two values are going to be get swapped over there. So each and every step you have to write. Yes, are you able to follow?
Ma'am, yes, theory you have to write code also, ma'am.
Yes, in the theory we have to write like this only.
You have to write the code also, ma'am, at the end.
Generally how they will give is no need of writing the complete code. They will ask only this one, what I have written just now. This part. Okay? You have to write. If they are going to ask algorithmic way, then you have to write. Okay, point 1, step 1, move the I pointer. Step 2, move the J pointer, decrement the J pointer. If I is less than J, swap the I and the J elements. If I is greater than J, swap the pivot element and the low element. Only 5 steps.
Okay.
So completely it's you people have to write like this. Compulsory, students, compulsory question. Because if we are going to see the number of theory questions in the data structures, we are going to have very few. 1 stack, 1 queue, 1 linear list, a linked list. And next one, we are going to have definitely 1 question you are going to get further from the sorting. Searching, they don't ask. Searching, they don't ask. Very few. If they want to set the paper in a very simple way, then only they will go for searching. Because linear search and binary search, you people are learning from the first semester. Why they will ask once again the linear search and binary search? In the 4th unit, you are having sortings and searching. So the paper will be, weight will be there on the sorting only. You people have to learn the function code as well as this code. Okay, you have to write like this. Whether any sorting techniques, you people have to write like this. Okay. Yeah, students, able to follow this?
Yes, ma'am.
Okay. Now what we have to do? This is the partition code. Now actually we have to call the quick sort code also. So how we have calling the insertion sort, and the array is going to be getting sorted. Similarly, if you are going to call the quick sort, take an array, take the lowest value, every time lowest value, and take the highest value. So in this quick sort algorithm, if lowest value is less than highest, means 0 is less than some position, then what we have to do, we have to call the code whatever we have written, that is partition code. A comma, L comma, H. So by this partition, we are going to get a variable called as pivot. Okay, we have return J over there now. So the partition, the first element is going to be gets its position. Now, before J elements and after J elements, again we are going to call the same quick sort algorithm. So again call the same algorithm, quick sort of A comma L comma J, means up to pivot. Quick sort of A comma J plus 1 comma I. So this is the code, students. So in a single function, we cannot able to write. Okay. So what we have to do, we have to take the array. First, what we are doing, we are taking the array, fixing the pivot element. First one, J gets its position. If J gets its position, the first part of the array, second part of the array. The first part of the array, A comma L comma J. First, again quick sort. Again we are coming over here. Again what we are doing? Again we are doing partition. Okay. Again subdivision, arranging all the elements in the ascending order. After the left hand side part has been completed, then what we are doing? We are doing the right hand side. Array, So this is the jth position. The first one pivot element j plus 1 to height. The remaining again what we are doing. Again we are calling the quicksort. What it is doing? It is doing the partition. Partition means again setting up the further division, further division, further division. So two different functions we have to write for quicksort, students. Otherwise it won't work. Okay, ma'am, it's lengthy program. If you are thinking, then you can go for the recursive algorithm. A choice is yours. I'm not going to say that you have to follow the same technique. So why I'm going to write explaining you in the same way means whatever the procedure we followed the theory, the same procedure I have written in the partition code. So now I know after this is the partition function calling. Left hand side a low j. J is the partition element. Right hand side a j plus 1 and high. I know what I am going to call. Okay, so that's why I'm dividing into three different parts. It's up to you, students. This is one of the code. You can write any of the code. Yes. Two different codes you people have to write. Are you there in the class? Are you listening to the class? Ma'am, Farida, we are.
Yes, ma'am.
We are. Yeah, we are. Here, students, please take down. Please take down. Check it out whether it is working or not. Yeah, students, I'm not writing the swapping code inside the function, just I'm calling the swap function. So swap function, so that's why I have written swap code separately. This we did in the selection and insertion sort also.
Okay.
Anyone are executing the codes?
Hello. अरे टॉपिक ఏంట్రా ఇది
Taking the screenshots.
హలో
I'm executing the codes.
టాపిక్ ఏంది అంటున్నా పార్టీషన్ ఏంటి అది అంటున్నా మరి పార్టీషన్ ఏంటిది ఇంత ఇప్పుడు
Check it out, students. Check it out if you are getting any error.
ఓకే
See.
ఫ్లిప్ సార్ట్ చెప్తుంది కదా ఓన్లీ థియరీనా ప్రాక్టికల్ కూడా రెండు just
Whenever you are going to follow any other code, okay, follow in the same way. Okay, in the same way. One thing you people have to remember. Whenever you are writing, especially theoretical, practical way, okay, fine, because whatever you are writing, just the code and you are executing, and that the same code we are sending to the university. The people who are writing the code in the theory part, please don't learn two different codes, students. Okay, while explaining, you have taken the first element as the pivot element, and you are making it as the center. While writing, learning the code, okay, so the other person has make it as a pivot element should be the last element. And they have written, don't write like that, you don't get single mark also. They simply think that you copied from somewhere. So what you are explaining and what you are writing both should match to the content. Remember this point, how you are doing the partitions. This partition is very, very important. So that's why I told you, whenever you are learning from the internet, so most of the cases, the last element is going to be considered as the pivot element. I am considering the first element is going to be considered as the pivot element. It's our wish according to our requirement.
ఓకే దాని తర్వాత ఒకవేళ ఈక్వాలిటీ ఇలా అయితే ఈక్వల్ లేకపోతే అదే నేను మధ్యలో సగం నుంచి
Don't follow two different techniques for it.
సరే ఓకే
Copy and paste. If I copy and paste, then everyone will execute. Okay, do some of the changes in the code, students. Yeah, I can copy and paste. Yeah, while executing the code, I want to discuss this point only. While I'm executing the code, the last value I have given it as 65,536. Okay. So still I'm taking the elements. The array is going to be repeating from 0 to 6, and even the quick sort also I'm going to call from 0 to 6 only. Okay, you please change the code and check it out. Don't enter the value. That is the maximum value I have taken. Means the J pointer is going to point from the last one. Change and check it out whether it is working or not.
Can you please repeat it and get it?
So the array elements, in some of the cases when the array elements is correct to the size, it will throw the error. The partitions, whenever we are going to do, it will throw the error. So that's why the largest element I'm going to take as the J. Okay, J is going to be starting from the largest element.
Okay.
So we are going to have some constant, now maxint 32 underscore. So you can work with maxint also, but it is not supporting in my system. So that's why I have taken 65. Always 65,000 should come at the last only. Okay.
Yes, ma'am.
Okay. Whenever you are doing the partitions, you may get this type of error.
It's working.
Okay. For your seniors, while I'm explaining, it is not considering the last element. So that's why we have included one more extra element, and that is the largest element. And then we started doing this quick sort.
It's working, ma'am.
Okay. Yeah, students, one more sorting is there, that is merge sort. Okay, this is the last sort we are going to have. So merge sort is the same thing. If you people, if you are convenient with the linked list, okay, you can work with the linked list, because I have seen so many of your seniors follow the linked list code. Okay. Suppose if you are convenient with arrays, okay, you can work with the arrays. The rule, the concept, what you have to work with the merge sort is, so if you remember the merge sort, okay, so we have to take two different arrays, first array and second array. Okay, so the array elements should be there. I need to merge these two concepts. Okay, so what I am going to say over here is the same code already we have learned in the linked list also, if you people remember. So one concept I explained, merging of two linked lists. In the starting single linked list, I explained merging of two linked lists. The same concept, the same code, if you are going to write, then also it is going to become as the merge sort. Okay, you can work like that. That is one of the way. No, ma'am, I want to write separately for the merge sort, then also you can write. I'm sorry. So what we have to consider is, it's not sorting. Bhargav only getting the problem, anyone?
It's working, ma'am. It's working, ma'am. Yes, ma'am.
Okay, so whenever you are working with the linked list code, students, please follow that two list ko you are merging. Okay, two linked list ko you are merging, or two arrays ko you are merging. So there are two different ways of merge sort. Whether question will not be, they are not going to be asked in a different way. Okay, so they are going to work in the same way. If I am going to take two different lists, okay, it should be in a sorted order, compulsory. Okay, one code is there. So why I'm going to say means I know so many people are going to learn in a different ways. So you people try to understand which way you are going to learn. Merge sort especially two different ways are going to be there. Take two different arrays and do the merging. Okay, the rule is compulsory. The array must be in the sorted order. Okay, then we are going to be arranging in the elements. Okay, first two will be arranged. So I pointer will be there. Here J pointer will be there. If I is less than J, yes, I is less than J. So I value is going to be there and I plus plus. I is going to be coming over here. Now I is compared with the J, which is smaller. J is smaller. So now arrange into the sorted order. Now J plus plus. J is coming over here. Okay. I is compared with the J. 5 is smaller. 5 has been placed. Next, I plus plus. I is shifting to over here. I is compared with the J. 7 is smaller. Insert into 7. I shifted. So I is compared with the J. J is smaller. 8. Next, J plus plus. J is coming to 12. 9 is compared with 12. 9. Next, I plus plus. 11. J plus plus 12. I elements are finished. Then 12, 15 and 17. This is one way, students. The same way I explained in the linked list. Okay. Some people have written this code also as also without linked list by using the arrays also the same way. I value, J value and start comparing and inserting into the array. Now the next way what we are going to have is, so if the arrays are not going to be in an arranged order and I don't want to work with the two different arrays, I want to work with the single array. So single array I am taking the elements like 2, 5, 7, okay, 9, 3, 8, 12 and 15. So these are my array elements. I want to arrange this array elements into sorted order. Okay, so now this is the another way. Now we are going to have one more way is also going to be there. So 8, 3, 1, 6, some 4, some 2, some 5. This is the another way. So there are multiple ways of working with the merge sort. Multiple algorithms are also you are going to find and multiple codes you are going to get. Fine. So each and every code will not support to the other code, students. Please remember this point. So what is the first way I'm going to say? We are taking two different arrays and arranging the same thing what we have learned in the single linked list. Now I'm taking single array, I want to arrange. If we are going to see this array, okay, so I'm going to divide this array into two parts. Okay, by taking a middle element. 2, 5, 7, 9, 3, 8, 2, 12. Okay, so now 2 is compared with 3. So this is I pointer, this is J pointer. 2 is compared with 3. 2 is smaller, arrange. I plus plus. Again, I is compared with J. J is smaller, 3. J plus plus. So it is similar, much similar to the code of this one only. This is one of the way. Okay, that's why I told you already we work. The another one, if I'm going to split the array into two parts, you don't find any array ascending order, either on the left hand side and either on the right hand side. Just a second, sir. So either on the left hand side or either on the right hand side, if you are going to see, we don't get in a sorted order, means neither this is sorted, neither this is sorted. So this code is different and this code is different. So learn the code in such a way that it should work for all the cases, okay? Or otherwise, if we are learning this type of code, please remember, take the example also in that way only. Okay, you have taken the example in this way and writing this code, your code is not going to be executed, students. So please remember this point in the merge sort, especially whenever you are going to learn the merge sort. Generally, the people are going to learn this way. This is the easiest way. Okay, if I'm going to give this numbers in this way, it won't support. Okay, the reason is here already it is in the sorted order and we are arranging the elements. Here none of the element is in the sorted order. So first one has been arranged, 2 is coming somewhere, because we are comparing I and J only, not one of the element in I and not one of the element in J. So please don't do such type of mistakes, students, while working with the merge sort. So this is going to be called as the way how we are going to sort this. This is called as two-way merge sort. So if you are going to search in the internet, this is two-way merge sort, and this is singular array merge sort, or merging the sort, or otherwise another name for this is merging multiple list. Each and every variable means we have to split each and every element as a separate array. 8 is a separate array, 3 is a separate array, 1 is a separate array, 6 is a separate array. Like this we have to split and we have to work. So how we are going to learn, that's up to you. I'm going to explain 2 different ways. One is working when I'm going to splitting an array into 2 parts. Okay, here multiple splits we are going to do, multiple divisions we are going to do in this two-way merge sort. In this only 2 divisions will be there. The array is going to be divided into 2 parts in such a way that the first element is compared with the second element and we are arranging the elements. So I don't get any problem. Okay, the elements are going to be arranged perfectly. Suppose if the elements are not in the sorted order, then I can't follow the same coding technique, whatever I'm going to write over here. Here we have to write separately. So 2 different ways I'm going to explain under the name of merge sort. So it's up to you which one is convenient for you. Then you can be able to learn. Here students, I'm not able to take the class. Okay, the next class I'll continue tomorrow. I think there is no class. If my health is supporting, then tomorrow I'll take this merge sort. Okay, so don't leave. Stay over there. Please give me your attendance before leaving the class. Sharish present? Yes, Advait? Yes, just stop, students. You are so fast. Anishri?
Present, ma'am.
Balasubramaniam?
Yes, ma'am.
Dipanshu? Devashish? Lalit Gita Reddy?
Present, ma'am.
Royan? Tangila?
Present, ma'am.
Rahul?
Present, ma'am.
Kulashekar? Uday? Rohan Kumar? Rakesh? Bhargavraj?
Yes, ma'am.
Niharika? Tiny Tingout? Vanchit Reddy?
Present, ma'am.
Ramya? Sign it in your present. Okay. Nitish Kumar? Your mics are not working or you don't want to work on talk only? Palash?
Present, ma'am.
Praveen?
Present, ma'am.
Pawar? Ritik Ranjan? Vishal? Sandeep Kumar? Aditya Rajkumar? Satyam? Aladdin?
Present, ma'am.
Akif? Pratimesh?
Present, ma'am.
Amya?
Present, ma'am.
Yes, Akash, not there. Jagannatachari, Akash, Ashish, Shamal, and Nilikanta. Okay. Yeah, students. Thank you so much. Test tomorrow. Yes, yeah, we are also.
Thank you, ma'am.
Yes, Ajay.
Yeah, thank you, ma'am.
Vaibhav.
Present, ma'am.
Aditya.
Present, ma'am.
Hemant.
Present, ma'am.
That's it. Yes. Okay, thank you, students. Thank you so much.
Miss, what happened to your head?